Hello students, you're welcome again to our class on Python programming. The class we are going to be having today is defined as the slicing of tuples and the removal of data from tuples. Let's get that written out so that all of us can be on the same page. The slicing, caps will be better for that. The slicing of tuples and the removal of data from tuples. Okay, that's our topic. The slicing of tuples and the removal of data from tuples. Very interesting idea. And where does this come from? Why is it so interesting? It is because, remember, in our first class, when we introduced tuples to you, we defined something interesting about tuples. And that thing was called the immutability of tuples. The immutability, my spelling, of tuples. The immutability of tuples. And what does that mean? This simply means that the content of a tuple can never actually be changed. The tuple must be destroyed or recreated to add content to it or remove content from it. And this law stands strong. And that is why in this case, we are looking at that. I know in some cases you might look at the slicing of a tuple as already removing data from the tuple, but mutability does not say you cannot create tuples out of a tuple. Do you understand? You are still destroying the original tuple. Not that we keep the tuple in some sense in a memory space, remove something from it and maintain it in that memory space. Python will not allow that because of the immutability of tuples. Now, if we remember very well what our tuples are governed by one very important fact. They are defined by two smooth brackets. Anything inside these two smooth brackets is data inside a tuple. For example, if I just say tup1 equals to this smooth bracket, I put a comma inside it, for instance. Even if I don't, it's a tuple, an empty tuple. Now we can start putting data like 5, 6, 7, 9, and so forth. This makes this a what? A tuple, as you can see. Now, this tuple data cannot be removed from it or added to it, but the tuple can be sliced. Now, let's first talk about the slicing of the tuple before we now talk about, okay, how do we remove data from the tuple and probably reconstitute the tuple. Okay, let's talk about slicing of the tuple. The tuple you are seeing here contains 4 elements, 5, 6, 7, and 9. My question now is, how do you slice this tuple? What kind of knife would you need? This brings us to the concept of syntax. And since this entire training is based on Python syntax, every time we have an operation to perform, like slicing a tuple, we will first study the syntax and then apply the syntax in our code editor. But for now, we stick on the whiteboard and explain to ourselves as much as possible before we move to the code editor. Okay, so a tuple. This is tup1, which is a tuple. Remember, you can always confirm it's a tuple by using the type command. And for those of you who are familiar with that, what would that look like? Remember, we're not using caps. We would have print, for example. Let's change our marker to red. So we would have print, open bracket, close bracket, 5, another bracket again, because you know this is a tuple, and inside there 5, 7, or 5, 6, 7, 9. Now let's take this to our code editor and see how this works. Okay, so we're going to copy this and take it to our code editor. Our code editor is here. Okay, so let's replace none with that. Okay, I think I copied something somewhere else before when I was writing code for a platform. Sorry about that. We'll copy this again properly. Okay, copy that. Let's paste it in our code editor. I'm going to have to cancel this. It seems my copy did not work. So we're going to just type it directly in there. I'm guessing the whiteboard copy should not work. So next time we're going to be using the whiteboard on our own platform, because Microsoft Whiteboard seems to have some limitations. All right, so we're going to print. Now, this was what we tried to print: 5, 6, 7, 9. And if we run the command, here we have print. So let's change that to n print. And if we run the command, let's run the code. Oh, we have 5, 6, 7, 9. But how do we know? It's because we didn't use type. So now we're going to apply type to see if it's actually a tuple. Let's do this on different lines so that it's not like we're cheating or anything. So I'm going to copy this code to the next line, and then here we're going to use the type command. But the type command has to come with its own brackets, because you cannot use the brackets on the tuple because that bracket defines the tuple. All right, let's run code again. Oh, you can see. So 5, 7, 6, 9 class tuple. So this is how you know it's a tuple. So print type something gives you the states or the class of that thing. Isn't that fantastic and just brilliantly interesting? Okay, that settles our score on that, and we are happy. Okay, so let's go back to the whiteboard, but this time around, let's copy this to remind ourselves how we can view the tuple, or should I say the nature of the tuple. Okay, so this element here, everything we've written so far here, is all about just defining a tuple and then allowing our program to tell us about if it's a tuple or not. We've not talked about slicing the tuple. How would we slice it? For example, tuple 1, which is 5, 6, 7, 9, let's try to slice it into tuple 2 and tuple 3. But before we talk about slicing, we have to talk of the syntax of slicing. So let's talk about that. The syntax of slicing. The syntax of slicing. The syntax of slicing. Syntax of slicing. Now, let's make that large so that we can see it and everyone around us can see that, because I don't want us to miss this. Okay, so the syntax of slicing. What's up with that? What is the syntax of slicing? So let's say we have a tuple. I wanted to slice it. We would simply put a square bracket in front of that tuple, and we have a colon. In front of that colon, we may or may not have a number. At the back of the colon, we also may or may not have a number. So, in front of the column, we would have a number which we could call A. And at the back of the column, we have a number B. Now, there are two characteristics about this number. These numbers, A and B, are going to slice the tuple. This word tuple, which is a variable name for a tuple that was created originally. Do you understand? To make it not too confusing, let us call this tuple tup1. Tup what? 1. Okay. So tup1 is sliced using the numbers A and B. So what does A do to tup1? And what does B do to tup1? That now gives us tup2. Because in this case, tup2 will be equal to this. A slice out of tup1. We can still generate tup3 with two different numbers also. For example, we can have tup3 being equal to tup1 being sliced with two different numbers, C colon D. Can we see that? Okay. And that puts the syntax of slicing somewhere where we want it to be. So from tup1, we've generated tup2 and tup3. So what does the numbers A, B, C, D do to the tup? First of all, we remember Python indexing always starts from 0, not 1. Okay. So for example now, let's make it real. Let's change our A to 2 and our B to 4. What does this mean? This means that the new tuple, tup2, will contain elements 3 and 4, but not elements 2. The elements having the index of the first number will not be present. The slicing will start from the next number to it, meaning that 2 colon 4 will be a tuple containing elements 3 and 4. If, in the other hand, we have C as 1 and D as 4, this tuple will contain elements 2, 3, and 4. Are we on the same page? So this one will contain the elements that you would get if you do tup1, 3, and the elements you will get if you do tup1, 4. But it will not contain the elements you will get if you do tup1, 2, because that is the starting point for the slicing. This is the thing with slicing. The same thing, if you were to use 1 and 4 to slice, your new tuple would contain elements, the element of tup1, 2, it would contain tup1, 3. Let me reduce that so that you can lift it up and then see it clearly. It will contain tup1, 3, and it will also contain tup1, 4. So your tuple will be elements with index 2, index 3, and index 4. But the element with index 1 will not be there. This is how slicing works. when it comes to slicing. We are going to go test this now by declaring tuple 1, tuple 2 in our code editor. Okay? Alright, so let's go to our code editor and confirm all this jargon that we have been talking about. So, instead of just print, we are going to define as variables our tuple. So let's go tuple 1 equals this. Alright, so I want to get tuple 2, and tuple 2, remember from our whiteboard, tuple 2 is tuple 1, 2, 4. 2 slice 4, can you see that? So tuple 1 square brackets 2 slice 4. Alright, so let's print tuple 2 and see what tuple 2 is. Okay, let's run this code. Oh, so you can see tuple 2 is 7,9, meaning when it was sliced by 2, 4, it did not pick element 6. It picked element 7 and element 9. In this case, remember, tuple is not counting, this slicer is not going to be counting from 0. It's going to be positional. For example, 5, 6, 7, 9. So it's looking at the elements like that. Okay. So let us move on to the next one. In this case, I think we are looking at the first and second element. So 0, 1, 2, 3. So it's not picking 4. It's picking 2 and 3, meaning the first one, the 2 is involved actually, opposite of what I said before. So the 2 is involved and the 3 is involved, but the 4 is not involved. So it's the last index it would not print, not the first one, the last index. So let's try that with the second tuple, which is tuple 3. So tuple 3 is 1, 4. Tuple 3 is 1, 4. Let's try that in our code editor. Tuple 3 equals tuple 1 divided 1, 4. So let's print tuple 3 and see the outcome. So in printing tuple 3, okay, what do we have? If we run this code, we now have 6, 7, 9. So if you look at it, it puts 1, which is 0, 1, and 7 and 9, but it doesn't take the last elements. Because there is no element 4, because this is 0, 1, 2, 3, let us add an element 4 to this. Let's call it 11. And let's run this code again. You can see the outcome does not change because it doesn't print the last element, the last index. It prints from the first index to the second to the last index. So when we have element slicing in 1, 4, it will print the first one, the element to the index 1, it will print the element to the index 2, it will print the element to the index 3, but dodge the last one. Okay, so let's scratch what I said earlier, which is dodge the first one. It's talking dodge the last one. Alright, so that clarifies this particular structure. So every time we want to give outcomes, it means we need to make corrections on this one. Tuple 2, 4 will then have 2 and 3, meaning the last ones will not be there. And tuple 1, 4 will then have 1, 2, and 3, dodging 4. So let's do one more in our index. where we can go deeper so that we can skip kind of the first one. So 0 to 4, for example. So if we do tube 4, and then tube 4 equals tube 1, and then we have 0, 4, then let's print tube 4. And then what would tube 4 be? Oh, 5, 6, 7, 9. 5, 6, 7, 9. It dodged the fourth one. So from 0, it not take 0. You understand? Obviously, it took 0, starting with 0. That's what I'm saying. It not take 4. That's what I mean. And so we have 0, 1, 2, 3, 4 elements taken. And number 4, which is the fifth element, is then dodged. So it means that for 0, 4, we have element 0, element 1, element 2, element 3, but not element 4. And in this case, element 4 is 11, and we can see it in pick it here. So this is a way of slicing tuples. All right. We've talked about slicing of tuples. Before our time is gone too far, because we've gone over 20 minutes in this class, let us quickly talk about removing data from tuples. So I'm just going to clear some of the data we have on my whiteboard here, and then just quickly touch on removing data from tuples. Okay. Removing data from tuples. Removing data from tuples. Because a tuple is immutable, as we all know, the only way to actually remove data from a tuple is to convert, but not the only way, but that's one of the easiest ways. We can always convert to a string, do some string operations. But one of the easiest ways to understand to remove data from tuples is to convert that tuple into a list and then remove the data from the list using the remove command. Because lists have a remove command, because lists are not immutable, then when you are done, you convert your list without now the elements you want to remove back into a tuple. Is that clear? All right, so let's do that. Let's do that. So the first thing we are going to do is, let's take an example of a tuple. Okay, so we are going to be taking tuple 1, obviously. Tuple 1, obviously, I think I like the word tuple 1. I mean, everybody should like it. It's a nice word. Tuple 1. So here now, tuple 1, let's embellish it more. Let's give it big numbers for 12, 34, 45, and 67. Now let's say we want to remove 67. And remember, tuples are immutable. The only way to remove 67 from this tuple will be to first convert it into a list using the lists command. And that means list tuple 1. That's tuple 1 as a list. Let's not forget that, because the variables are getting compounded. List tuple 1 would then be tuple 1 list. The list command, remember, code is in small letters. So the list command with tuple 1. Now this has converted the tuple 1 into a list. And the name of the list is list tuple 1. Okay. Now list tuple 1 is a list. Therefore, we can apply the remove command. And to apply the remove command, we simply write list tuple 1 dot remove. Remember, our code is in small letters, so dot remove. Now what are we removing? 67. Now you can call it 67, or you can call it element 3. index 3. So let's call it 67 for this case. So we want to remove 67. You understand? Now look at this. If you notice, when we write our code, we always equate to something. But there are some lines of code that if you equate them to something, it will give you none because it is not a data serving command. It is, however, a memory changing command. So list tuple1.remove 67 remove 67 from the memory space called list tuple1, but doesn't output any value. So if you try to say like a equals to, for example, if you come here and maybe you are thinking that it will give you the list of it has removed from, and you go a equals to list tuple1.remove 67, a will be none, because this is a single line code. It is a code that changes the content of a memory space but doesn't give out a result. Now there are codes that can be applied like this, and there are some that gives you the outcome. But this one just changes the point. So we're going to try this in the code editor and we'll see how that works. So normally we don't do this. So I'm going to leave this here and write wrong in the bracket. Okay, wrong. And then we'll do the correct thing, which is just this tuple1.remove 67. Okay, so be careful about that. And then on the next line, we then print list tuple1. Now we convert it back to an index, so it's better that way. So conversion time. So we can say tuple1, which is our original tuple. Tuple1, we can use the same thing. Now we can say tuple1 removed, tuple1 rem is now equal to, let's not repeat variable names, that's why I'm saying tuple1 rem, but if I'm rushing, I'll just use the same rem, the memory will be replaced and then blah blah blah. But let's leave it. Tuple1 realm, which is the tuple1 where the element has been removed, will be equal to tuple, because the same way you have list as a command to convert a tuple to a list, you have tuple as a command to convert a list back to a tuple. So it will be equals to tuple list1 list tuple1. All right. Okay. So this is now officially tuple1 realm. Okay, so I'm going to try to reduce the size of this so that we can look at it clearly. Okay, so cool. So we have tuple1, we have list tuple1, we have a equals list tuple1.remove 67, wrong, list tuple1.remove 67, that's the right way to do it. And then tuple1 rem, we will then print tuple1 realm. I think I'll just copy this and paste it in our code space, in our code editor rather. And I also want to print A so as to teach us what the value of that thing is. All right, so let's okay, sorry, I hit Ctrl S there instead of Ctrl A and Ctrl C. Okay, so let's go to our code editor, see if we can do that. Okay, there it is. Let's run the code. Okay, we have an error. Oh yes, it's telling us wrong is not defined. Yeah, sorry. I'm going to have to comment it out. Yes, of course, wrong is not defined. So let's hash it. Okay, so now we can run it again. Okay, so we are looking at list.remove x where x is not in the list. Okay, so you can see now the list.remove was applied twice, and that gives a problem. So because the second time 67 is no more in that list, that is why it's saying list.remove x is not in the list. So even though this one A is going to give us none, it has, this part has worked to solve the problem. So we want to see A as none. So the first thing we do is let us comment out every other part of this code to first confirm the non-nature of A. All right, let's run this again. Okay, so you can see none. Oh, none. Why? Because this is the wrong way to write this code. A is useless. It doesn't give any outcome because list.remove only does operations inside the memory space and not outside of it. Okay? All right. Okay. So now what we are going to do is, we've gotten to 30 minutes on this class. That is way too long already. All right, so we're going to end it here. And then let's just remove. Now we are going to caution A. We already know that. Let's comment A out. So we'll then do for the others. Let's come. So let's run the code now. And we should have our final. 1345. That's what tuple, meaning 67 has been removed from the tuple. Okay, beautiful. So for classwork, what you are going to do is you are going to generate 5 tuples, remove their first and last elements, and then print out the results. And also another 5 tuples, and then you slice them into 2 different tuples. This is the assignment. Thank you very much. You can always rewind the video to hear the assignment again. Okay, enjoy your day. So my name is Ayo Gbadebo, and you can reach us on our Nigerian phone number at 081-3662-8035 for the Codex of Fidian training, and to take advantage of the tools and the classes we have for you to understand Python. Thank you very much. It's been a pleasure being your tutor.